Okay, so now we're on 1.2 in Trig, and 1.2 in Trig is modeling equations. So let's see how modeling equations can be. Guidelines for solving word problems, because that's basically what this is. You want to read the problem several times. As stupid as that might sound, you need to do that, because whenever you're looking at these types of problems, it's hard to see what the answers are unless you do it a couple times. Introduce some letters for unknowns. So what you don't know, you want to put a letter in that spot and try to solve for it. And if it can help, you do want to draw a picture, and trust me, that can be very helpful. And list all the unknowns and the knowns as well.
They're dogs, and they're playing poker!
So, more guidelines for solving word problems. Then you make the equation at the end. And then solve the equation and check your answer.
Doing it?
Okay.
So, example 1. A student in an algebra course has test scores of a 64 and a 78. What score in the third test will give the student an average of 80? So, average. Basically, when you're finding an average, that means you add all the numbers up and you divide by however many they are. That's how you find the average. Well, we have a 64. That's the first score. We have a 78. That's the second score. The third test, I don't know what it is. So once again, introduce the variable. There it is, x. Then you're supposed to divide by however many tests there are, which is the 3, and that will give you your average of an 80. So basically, there is your equation to solve. And the reason why their x is in here is because it's the test we don't know. We're finding the average of 3 tests, which is why that 3 is on the bottom. So I combined the sides here because this is a 3, so I'm going to multiply by 3 on both sides to get rid of that fraction. Who wants the fractions? When I do that, I have 64 plus 78 plus x equals 240. So I combined these two together, and that'll give me 142 plus x equals 240. So to solve for x, I minus a 142. And I find out that I need 98. So what that means is if that student wants to have an average of 80, they're going to need to almost get 100% in order to get an 80 average overall. So keep that in mind when you are doing the problems. So check your answer to see if it makes sense. Okay. So see if it makes sense.
I got family here from around the globe.
Alright, so a clothing store holding a clearance sale advertises that all prices have been discounted 20%. If a shirt is on sale for $28, what was the pre-sale price? So basically what we mean is, what was the price before? We're trying to figure out what it was. So if the shirt is discounted 20%, you get the shirt for 80% of the price, right? That makes sense. So the shirt was 100% and they're taking 20% off of it. So now you're getting it at 80% of the price. So 80% of whatever the original value was is $28. So that's the equation we're trying to figure out. We're trying to figure out, hey, 80% of the original value is how we get this 28 bucks. So what is the original value? Well, to solve with percents, we have to rewrite it as a decimal, so that's 0.08. So I divide by 0.08 on both sides because, or sorry, 0.80 on both sides to solve for x. 28 divided by 0.8 is 35, so the original price was $35. So simple interest formulas. There's a formula, I equals PRT, that's the principal money that you're putting in. I stands for the interest. This is the money that you put in. R is the rate, as in a percent, and T stands for time, which is normally in years when we're talking about simple interest. So, an investment firm has $100,000 to invest for a client and decides to invest it in 2 stocks, A and B. The expected annual rate of return or simple interest for stock A is 15%, but there is some risk involved. Thus, the client only wants to invest $50,000 in the stock. The annual rate of return on the more stable stock B is anticipated to be 10%. Determine whether there is a way of investing the money so that the annual interest is 12,000. So let's look at 12,000. Stock A is X times the rate, right? Because I don't know how much money I'm putting in yet, but I do know that it is 15%, and the time is after 1 year, because we just want to know what happens after 1 year. Stock B is going to be, well, I don't know how much to put in stock A because that's what we're trying to figure out, but I do know that I have a total of $100,000, which is why it's 100,000 minus the X. And the reason why this works is if I put 10,000 in here, then 10,000 plus what gives you 100,000? 90. Well, how do you figure that out? 100,000 minus 10,000 is 90. That's where this formula is coming in. So whatever this is, 100 minus that number will tell you what you're investing in stock B. And said stock B is at 15% for 1 year. So here's the formula: 0.15x, because 1 times 0.15 times x is 0.15x. Then I have to take this and distribute it through. So 0.1 times 100,000 and 0.1 times a negative x. So I have a 0.15x plus 10,000 minus 0.10x. So 0.15x minus 0.10x, those two I can combine together. And when I combine them together, I have 0.05x plus 10,000 equals 12,000. So to solve for x, I would subtract that 10,000 on both sides. So I get 2,000 equals 0.05x. So I divide both sides by 0.05. And when I do that to solve for x, I cancel out, saying that what that means is I would invest $40,000 in stock A, and in stock B, 100,000 minus 40, I'd invest $60,000. So 40,000 and 60,000 in stock B. That would determine my way to anticipate what to put in each stock. So if we continue here, what if it was 13,000? Same setup, everything's the same, right? Notice how nothing's changing. It's still 1 year. It's still 100,000 minus x, and it's still 0.1. Everything's the same. You notice the only thing that changed from the last problem to this problem is it's now $13,000. So even all this work that we just did is all the same, right? All this work of me getting 0.15x, me distributing that, it's all the same. The only difference is instead of 12,000, right? Instead of 12,000, it's 13,000. See? Same as the last one. Here's the proof just in case you didn't write it all down. Everything is the same. See? There's the formula, except instead of 12,000, it's 13,000. So everything is the same. So to solve, I would minus the 10,000, so I have 3,000 equals 0.05x. So I divide both sides by 0.05. And when I do that, I get 60,000, which means I'd put 60,000 in stock A and 40,000 in stock B. That's if I wanted to get $13,000 back out.
Okay, folks.
Okay, so when we come back here, we will finish up, try to finish up anyway, on the rest of these examples for some word problems in 1.2 in Trig.